So, quickly before we move on to 5.3 is the idea of passing by value or passing by reference. This is a quirk of the way that computers work. This is a quirk of the way that storage and referencing works. And I'll go into the long explanation here so you have it and so that you never need it again. When we finally build a Java virtual machine, and inside of the Java console, we actually get all of your code to run. We have to worry about things like storage. We don't have necessarily an infinite amount of stuff that we can use. Now, here in, the 20 or the 21st century, that is not something we worry about, right? Even the shittiest computers on campus, so like the instructor machines, even the worst computers on campus have 8 gig of RAM, whoopee, and 2 gigahertz processors, whoopee. And that's really all the space we're ever going to need to be able to do something little like we see here in any of the examples really that we can see here through chapter 5. They are, a couple of dozen kilobytes worth of storage space that's necessary. It's a couple of hundred kilobytes for the compiled code to be able to run. That's really no big deal at all. Now, that wasn't true for the entire life cycle here of Java, and that certainly wasn't true of the life cycle of the languages that Java inherited from. So like C++ and C and Pascal and other languages that are older than me. And the idea is that an argument should be passed by value so that you still have the original copy. So what we're saying is when we pass to a method a parameter, we're really not taking the thing it is that we're referencing. We're taking a copy of it. So that I say, okay, you have inputted 5 for the number in our previous example here in 5.2. So we were saying that x equals 5. So rather than pass the only copy of x that I have, that's dangerous, right? What happens if something happens during that function call? What happens if we lose power? What happens if we lose network connectivity? What happens if something else is running on our system and it prevents that function call from being executed in a reasonable amount of time? Now, the one and only copy of X that I have is lost. It is gone. And sure, in a 10-line piece of code, whoopee, what does it mean that I've lost that? Nothing, right? All I have to do is start the program up again. It's all hardwired into there. Big deal. Now, that's not what happens in a large-scale development where one function call, one method call, might be damned important to the overall function of your program. It might be damned important to the overall use and functionality and ability of that whole program. So rather than give over the one and only copy that we have, because that's extremely dangerous, rather than do that, we'll make a copy of it and we'll pass that along. So this way, the called method, so the method it is that's going to do the work, can do the work on a copy of it. And if something goes wrong, we're not totally screwed. But it does, for the budding developer, it does have some issues that come along with it. So because we're only passing a copy over to our called method, that means that we potentially never change inside of our calling method. So inside of main, for example, we never change that value. So we are going to see the idea of scope coming up here in chapter 5. And, what happens when we change the value of x inside of our called method, but it's not really changed inside of main? That can lead you as a developer to a lot of confusion. But I'll tell you honestly, The way it works is preventing heartache and tears because we have the original, we have a copy. Now it's up to you to remember to do something with the result for that original. And the way we would deal with that is instead of just making a function call, like you can see here, this is on page 285. I hate when it does that. This is on page 285. So here, we are calling change me on line number 17 of our code sample here. And really all that's going to do is change a copy of that value. That's no good to us. We would have to assign the result of change me to a variable within main. And that's something we're going to see. It's in 5.3 here coming up next. Now, the other side, excuse me, the other side to passing by value, so a copy is passing by reference. Now, we're getting into the weeds, and I understand that, but we already started in the weeds, so we're just going a little bit deeper. I think it's probably okay. When we are working with objects, so remember, a string is an object, and for right now, that's the only kind of object we really have to be concerned with. When we're working with strings, the problem or the challenge with a string, now again, this is less of a challenge now in the 21st century where we have more storage and more RAM and more processing than we know what to do with. But previous to that, we did not have more storage and more RAM and more processing than we knew what to do with. We wanted more storage and processing and RAM, and we knew damn well what we were going to do with it. More. So instead of passing a copy of a string, now remember, a string is way bigger by default. It's way bigger than an integer or a double or a floating point number is. And actually, strings can get to be really incredibly large. So rather than pass a copy of something that might be incredibly large, we'll simply pass the address, its storage location. So we're saying, like, instead of passing a string that is, let's say, the dictionary can fit inside of a string. Now, that's a pretty long string, right? Now, we have return characters, we have periods, we have new line characters, we have all those things stored inside of it that can help us actually print a dictionary, but it can be stored as a string, an incredibly long string. So instead of passing that incredibly long string, which we may not actually have the storage capacity for, as a matter of fact, here inside of Replit, we can actually run out of storage because Replit is only giving you a tiny itty bitty fraction of a tiny itty bitty virtual server out there someplace, so you can run out of storage space or processing power. It will happen, maybe not right now, but it will happen. So instead of passing another copy of this huge string to get another copy back, now we have two copies. If we call another function, I have to create a third copy. Now I have three incredibly large strings to receive another copy potentially back. Way too much space. So instead of doing that, on an object, we provide, instead of a copy, we provide what is known as a reference. That reference is a storage location. It is an address that we can use. So when your function receives as an argument the reference, it goes, oh, I have to go here for the one and only copy. And that's, as a matter of fact, what it does. So when you are working with objects, so for right now, you can say when you are working with strings, they are immutable. So we are actually going to make a copy of that because a string cannot be changed once it is assigned a value. So to keep things efficient, when you are using strings or when you are using objects, you don't get the full copy. You simply get a reference to the copy. You get an address where it can be located, and because strings are immutable, that means they cannot be changed. It will be making another copy of that. But instead of passing all those copies around, which can get, frankly, damaging, we simply pass the address to where the copy of that is. That is far smaller, it is far cheaper, it is far faster than passing the whole thing over. And that's why we do it with objects, so strings here, because that amount of space can be precious to the overall running of a program, and we want those things to be as efficient as possible. So there's two ways to pass those arguments. You can pass by value, which is a copy, and that is reserved for things like ints and char and double, etc. Or you can pass by reference. That's for things like strings, because a string is an object, or objects, which we will see later on.